Okay. Okay, so this is the content of this topic. We'll look at the databases, the types of databases, pre-database information systems, database approach, database management system, commercial implementation, and the relational databases. So by the end of this topic, at least you'll be able to describe the features of a database system. You understand the role of the database management system, the DBMS, describe pre-database information systems, and understand the importance of a relational database. So what you have seen there, it's a database or a data in Microsoft Access. That's how the database look like. As you can see, there's a field name, the field names, the field IDs, the IDs are listed below. The field names, the names are listed below. Certificates, the certificates are listed below.
No, can't see anything.
I haven't shared.
Oh, yeah, no.
You can't see? Okay, I think you can't see. Let me share. Okay. Okay, you can see now?
Yes, yeah, yes.
Okay. Right. So I was saying, those are we've got the Microsoft Access database done in Microsoft Access. So you have the field names. The first field name is the field ID. The field IDs are listed below. We've got the field name called field name, the field name called field name, the certificate, rental, and a content. So this database is already, it's information given, unlike the other one which didn't have the field names. Then what you see there, it's a database or a data in Oracle. Oracle is another DBMS, but the only thing about the Oracle, it's expensive. You need to buy in order for you to use this software. So we've got employee number are listed first, then employee names, the job, management hire date or the manager hire date, the sales, commerce, and the department number. Now, metadata, what you see there is a metadata. Metadata, when they ask you, but what is metadata? Metadata is data about data. Metadata contains the data dictionary. Metadata contains the database dictionary. So metadata, we've got the name, which includes student name, student ID, date of birth. Data type, which is written as type. There is a character, a number, and the date. Then the length can be 50, meaning that a student name can only contain 50 characters. If a name contains more than 50 characters, it can't be entered. It can either less or equal to 50. Then we have a description. For instance, a student name, what's a description? It's a student name. Student ID, what's a description? Student ID, it's a unique identification number of a student. By the way, student ID is a primary key. We are going to hear most of the time primary keys and the foreign keys. Primary keys, this is a unique identification of an object, a unique identifier of an object. Then you are going to hear the foreign key. Foreign key references the two tables. Foreign key makes the relationship between the two tables. Okay. Metadata in Microsoft Access looks like that. Metadata in Oracle also looks like that. So what is metadata? Metadata is data that is about data. It is the way in which the database keeps information about its own structure. It's important in understanding how data can be independent of application in the database approach. Metadata is stored in the data dictionary. Metadata is stored in the data dictionary. Define metadata for data about the following: student in a college database, books in a library system, holidays booked by a person at the workplace. Try to think about what data needs to be kept. Will it be a character? Will it be a date? Will it be a number? This determined with a data type. For instance, if I say student ID, what are we going to store in the student ID? Remember, student ID is a number, isn't it? So the data type will be a number. So meaning that in that field, you are going to be storing, or you're going to be keeping the numbers. You're going to be keeping the numbers. What you see there, it's a diagram of the two-file processing system. Two-file processing system. What you see on the right-hand side, where it's written customer file, where you have the actual database is kept, saved. Then on the left side, you've got customer file user, isn't it? Then in between, you've got a customer processing system. So in between, that's where the DBMS is. Remember I said a DBMS, it's a software that is used to create the database. So what you see there is the database. It's a customer processing system database, which is in between the customer file user and the customer file itself. So customer file itself, that's where we have the database. So the customer processing system is the one which is interacting with the customer files, isn't it? Then the customer file user, the users, these are the forms, these are the applications which are programmed in various programming languages. They're the ones connected to the database. So what you have on the left side, it's an application programmed whether in C or in C++ or in C#, connected to the customer processing system, which is a database. So you as a user, you interact with the customer file users, isn't it? Are we together? You are quiet.
Oh,
Are you
it's
there?
lost you there.
You are lost.
Yes.
Okay. I was saying,
No.
when you do a program in, let's say, a Visual Basic, it's an application that you have designed, isn't it? That you have developed, isn't it? This application, at the end of the day, it has to be connected with a database. Without a database, this application can't do anything. Okay? Then the actual database is saved in the customer files. So the customers, when you sit on the computer and request for something, they actually go to the DBMS. The way you are seated on the computer like that, when you request for something, even on Google or whatsoever, they go to a DBMS, which we see in between. Then DBMS is requesting from the actual database. So it's a two-file processing system like this. The way you see it like that, that's how it is in reality, actually. Then we have a rental file users also connected to the DBMS for rental processing system, then a rental file, which is the actual database. So those diagrams you see there, that's how the database and the system are actually located. So that's the architecture of the database, the system, and the application. As you can see, we'll look at the detailed one. First of all, just a minute. File processing system, Okay, data are separated and isolated. Data are separated and isolated. Data are often duplicated. Application programs are dependent on file formats. Files are often incompatible with one another. It's difficult to represent data in users' perspective. Okay. Okay, then that's the basic structure of a database. As you can see, there is one database on the right-hand side. There is one database on the right-hand side, isn't it? Then DBMS,
Yes.
also in the middle. Then we've got three applications, which was three users, meaning three applications. We've got one user is for customer processing system. Second user, rental processing applications. Third user, other applications. It could be HR or it could be procurement or anything. All these are connected to one DBMS. As you can see, it's one DBMS, isn't it? Then one database. Are you able to see that?
Yes.
Okay. Then the detailed one. The one in the middle, this is the database management system. DBMS serves as intermediary between user and the database by translating user requests into the complex code required to fulfill those requests, application requests. Then application programs on the user side. These applications might be written in programming languages such as Visual Basic or C++, C#, V, C++, C#, C, Python, or any language. There are so many languages. Or it might be created through a DBMS utility, e.g. access forms wizard, e.g. access forms wizard. Then the drum there, that's where we have the metadata. That's where we have the data itself. That's where, that's actually the server. That's the hard drive. That's physical component, isn't it? Then DBMS, it's a software. Then applications are the ones now installed in the computers for the users. Features of the database approach: integrated data, reduced data duplication, program independence, easier representation of users' perspectives. Database systems are self-describing. Database systems maintenance, program data independence. A database is a model of a model. So those are the features of a database. When you're writing exam, they'll ask you, what are the features of a database? They will tell you those, you have to write those. Common application, we're talking about forms, reports, web applications, batch processes. Those are the common applications. Oh, okay, you are back. It was just the internet. I don't know if it's still recording. I don't know if it's still...
Yeah, I think it's recording.
Oh, it's recording, okay. That's okay. So the DBMS architecture, there is a kernel, toolkit, and interface. That's the architecture of the DBMS. If they ask you to draw the architecture of the DBMS, you should draw something like that. There's a database inside the DBMS kernel, and DBMS kernel followed by the interface and the DBMS toolkit. These are the applications. DBMS toolkit are the applications. There are types of toolkits. Okay. The internet. Okay. All right. Then okay, then the DBMS functions, there are quite a number. One of them is CRUD functions. You have to know what a CRUD function is. Data dictionary, transaction management, concurrence control, recovery, authorization, data communication, data integrity, administration utilities. DBMS interface functions. There is data definition